And now using that, we can go ahead and use these two methods to solve real world problems. And so examples 3 and 4 are just some kind of word problems here to look at. And so example 3, suppose that $250 is deposited into an account that pays 4.5% compounded quarterly. The equation A equals P times 1 plus R over 4 to the nth power. So that should look kind of familiar, right? This was our compounding interest, 1 plus R over N times NT kind of equation we looked at back in, I think it was chapter 8. So that should be at least a little bit familiar looking. Gives the amount A in the account after n quarters. That's important to note, right? N doesn't just represent like number of years, it's the number of quarters. And there are 4 in a year, so 4 quarters. For an initial investment P, so P is our initial investment that earns interest at a rate R. Solve for N to find how long it will take for the account to contain at least $500. So just important things to notice. Suppose that $250 is deposited. Okay, that's going to be our initial amount. So P is $250. Do we know what R is? Do we know what our interest rate is? Yeah, it's 4.5%, which translates to 0.045 as a decimal. And says solve for N, so we're not going to know what N is, but do we know what A is? Do we know what that account amount is at the end? Yeah, it tells us we want it to be $500. So A is going to be 500. So if we put this into an equation, we have 500 equals P, so 250, times our 1 plus R over 4, so 0.045 over 4 to the power of N. So now our goal is to try to solve for N. So we're going to do this algebraically, and then I'm also going to show you that we can double check this using the graph. So you do need to know how to do this algebraically, because you're going to want to show that. But then again, being able to use the graph to kind of help check your work, again, is going to be really valuable when it comes to working on your test. So in this case, we have our N is attached to this number right here, and 1 plus 0.45 over 4, we're just going to quickly figure out what that is. So I'm going to go to Desmos. What is 1 plus 0.045 divided by 4? And since there's not a ton of decimals, I'm actually just going to use them all. So 500 equals 250 times 1.01125 to the power of N. Again, if there was like 10 decimals or something like that, I'd probably round a little more, but there's only 5 decimals, so that's not too bad. And now we're going to get N by itself. So again, our N is attached to that number, so we got to get rid of the 250. So we're going to divide both sides by 250. 500 divided by 250 is 2, equals 1.01125 to the power of N. And so now how do we get rid of that? Well, again, if we have log undoing an exponential, right, our log base needs to match that base. So we're going to have log base 1.01125 of the right side. And the same thing on the left side, log base 1.01125. And so we get log base 1.01125 of 2 equals N. And again, right, because of the graphing calculator capabilities, we can actually just put that into Desmos. If we didn't, we would need to convert that to log of 2 over log of 1.01125. So again, just kind of 2 different ways you can go about finding this answer, depending on what access to a calculator you have. For us, we're just going to go ahead and put this one in since we can. And so we're going to find out that the log, whoops, wrong log. Log with a base 1.01125 of 2 is 61, approximately 61.959. And so remember, these are quarters. And so, yeah, that's a good answer, but when we're talking to people, it's like, well, what does that mean, right? So remember, if that's quarters and there are 4 quarters in a year, all we have to do is say, okay, what is this number divided by 4? So if we divide it by 4, I'm actually just going to do that in this box, divide it by 4, we get 15, or you know what, I'm just going to go back a step, sorry. I'm going to go ahead and just type that decimal in. 61.959 divided by 4 gives us approximately 15 point, we'll just say 15.5 years. Okay, so the 61.959 quarters is not a wrong answer, but again, we just typically like to think in terms of years, so it helps to know that conversion, right? Hey, this was 15 years. It's a lot easier for our brains when we talk to somebody about that to say, oh, okay, 15 years, like that we can actually visualize that amount of time. And the visualizing quarters is just kind of hard for us because we don't deal with that very often. Okay, so either one of those answers would be fine. And again, we can check this on our graphing calculator. So I'm going to go back. Remember our first step we could have done, or what we can do, is say what is y of 500, or sorry, y equals 500. Let y equal 250 times 1.01125 to the power of n. And so if we do that, go back up here to the top since I already got these up here. Y equals 500. Y equals 250 times 1.01125, the power of n, which is just x, but I'll put in n. And if we go back home, try to go find our graphs, there they are. And we can tap on that and see 61.959, which is what we had for the amount of quarters. Okay, so again, being able to use the graph, like having access to your graphing calculator on your test, can be really helpful. Because yes, I do want to see this scratch work, right? I do want to see you actually solve it algebraically, but then you can use this, right, the graph, to help check your work. Okay, so you will need to be able to show that you know how to do it algebraically, but you can use the graph to double check and make sure that you're right. And so example 4, how long will it take to triple a $250 initial investment in an account that pays 4.5% compounded quarterly? So again, it tells us quarterly, and that's important to notice. So we can basically use the same equation here. We just have different starting values. So how long will it triple a 250? Well, remember, tripling means 3 times. So this would be 250 times 3, so my A is going to be 750. Our principal amount, our initial amount, was 250. And our rate this time, it says, is 4.5%, so 0.045. So now we have 750. Equals 250 times 1 plus, again, that's 0.045 over 4, because we're in quarterly, power of n. And again, that fraction becomes that 1.01125. Start off dividing by the 250 in front to get rid of it. This time 750 divided by 250 is 3, equals 1.01125 to the power of n. To get rid of that base, we're going to do the log of base 1.01125 on both sides. gives us the log of base 1.01125 of 3 equals n. And again, we can put that into our calculator. I'm going to scroll down here where we did the last one and just put in 3. And so it tells me that n is approximately 98.203. And this is in quarters. So if we want to figure out how many years that is, again, we just simply divide by 4 because it was quarters. So on our calculator, 98.203, and that gives us approximately 24.6 years. Okay, so again, either answer is fine there. I'm not looking for, it didn't say specifically how many years, it just said how long. So as long as you label the measurement of time, you're fine. But again, it does kind of help to know because it makes more sense for our brains to know the years, because that's just, again, a measurement of time we use more often. That makes more sense for us. Okay, so that is it. That is 9.4. Again, it's kind of some stuff we've already looked at before, but now just kind of focusing more on that aspect of it. But if you have any questions, again, come by and see us during lunchtime. But otherwise, you can always reach out, message us, and we'll try to help you when we can. But you now have your 9.4 practice to work on. And a reminder, you've got a test coming up. So if you have any questions from Chapter 9, please make sure you're getting help, you're practicing, going through those example problems, and asking questions if you got them.